Okay. Good evening once again. Welcome everyone to today's lightning session. Um, so our speaker for today is Mr. Bright Asui. He has taken us on two sessions on lightning talks, and yeah, welcome Mr. Bright Asui, and welcome to. So today's topic is very fundamental and not just for junior developers, also for senior developers. Yeah, just to wrap your head around the basics again. Yes, OOP is the fundamentals of um, the modern programming language as it is. So it cannot be overemphasized and it cannot be overtaught. Yeah, so today, Mr. Brightas will be taking us on that journey again. We've done it before, or probably we've not touched the concept he'll be taking us through. So, um, without further expansion or exposition on that particular topic, um, I would invite Mr. Bright to carry on. So, Mr. Bright, you have the floor.
Hi, good evening, everyone. Can you hear me?
We can hear you, Mr. Bright.
Okay, so
We can hear
if
you.
at any point you stop hearing me, just let me know because my network is not so stable this night.
Okay.
Yeah, so let me quickly share my screen. Yeah, so I believe you can see my screen, right? Hello,
Yes, we
hello.
can. Yes, we can. We
Okay.
can.
All right. So good evening, everyone, once again. Tonight I'll be speaking on object-oriented programming and some practical applications of it. Just a little disclaimer for our seniors in the house. This will be more of a beginner level, right? So more with basic examples, to carry everyone along. Yeah. So can you hear me? Hello?
Yes, we can hear you clearly.
Okay, thank you. So the table of content, though not just limited to this four, but we'll be starting with what is object-oriented programming, introduction to class and objects, pillars of object-oriented programming, composition and aggregation. So over the next 30 minutes, I will develop on these four core areas. Yeah. So let's get started. What is object-oriented programming? So object-oriented programming, OOP for short, is a programming paradigm, okay? That is, it's a way of thinking about and structuring code that organizes software design around objects rather than functions or logics, right? So I know this is a whole lot of grammar, but I'll break it down as we proceed. So, is a programming paradigm. We have like so many other programming paradigms. So we have the procedural, we have the functional, also have the OOP, that is the object-oriented paradigm. So in this paradigm, you are structuring your code around objects, around tangible things, right? So rather than just functions, like when you write your Pascal and your basic code, right? So what is an object? An object is basically a real-world entity that has attributes, which is your data fields, your attribute data field, right? And behaviors, which is a method. For example, let us take example. Emeka is a student, right? He has a height of 6 feet, right? That height of 6 feet is the attribute, and he can read and can write. So that can read and can write is
Mr. Bright, your voice, we can't hear you. You're not audible.
my
Mr.
network
Bright,
is poor.
you can continue.
Okay. All right, so you can't talk about OOP without mentioning
Hello, Mr. Bright. Hello. Hello, Mr. Bright. Do you have to join and do you have to rejoin? Hello. If you can hear me, we can't hear you. Okay, okay, let's give him a minute so he can join. Okay, he's about to join now. Let's just join. Apologies for the glitching network. I have to share my screen for him. His network is very bad.
houses. You also use, your classes
Hello,
to
hello,
construct your objects.
wait, Mr. Bright.
Yeah,
Yeah, you went off.
I guess
You
my
went
network
off.
went off.
Yeah, you went off. We couldn't hear you
Oh,
for the past
oh,
three.
sorry. Please, can you hotspot me, please? Sorry, I think my network.
Yeah.
Let me change to a different network.
Okay, I will share. Let me share my screen for you so that you can use this slide on my side.
Yeah, sorry for that. Sorry for that. I'm back. I'm back. Let me quickly reshare.
Okay, okay. That's
Yeah. Okay, okay. Sorry for that. So previously I used a house analogy whereby Emeka used one house plan to construct as many houses as he wants, and most of those houses all look the same aside from painting and stuff, right? So I tried to bring that analogy into the class, saying that okay, class is like a blueprint for creating an object. So with one class you can create as many objects as you want. That was what I said earlier on. So let's go to the next slide. Then introduction to objects. Okay, somebody raised hand.
Yes, Mr. Bright, good evening.
Yeah, good evening.
Okay, you actually stopped at where you were talking about attributes with Emeka
Okay.
before you.
Okay.
Yeah.
Sorry. I guess my network did me something bad. Okay, so I say that that an object, represents a real-world entity that has an attribute and behavior. And I said, for example, let's take Emeka as a student. He has a height of 6 feet. That 6 feet is his attributes, right? Now, he can read and he can write. That he can read and he can write are his behaviors, right? So Emeka.
Hello, Mr. Bright.
I say that, class is like a blueprint, is like a
Hello, Mr.
blueprint for
Bright.
creating an object.
You, Mr.
Yeah,
Bright, you
can you
have
hear
to
me?
go back again. We didn't hear your voice. You skipped a bit.
I guess my network is doing me my bad. Now time is fast going. Can you hear me better?
Yeah, we can hear you now. We can hear you.
Can you hear me?
Yes, we can.
So let me change network, please. Let me. No internet. Can you hear me? Can you hear me?
Yes, we can hear you. We can hear you.
Sorry, I don't know what is happening tonight. My network is just going off and on. Okay. I will just rush through it so that we can see meet up with the code examples. Okay.
Hello. Hello, Mr. Bright.
Step-by-step instruction on how to do something, right? Good. And I gave an example of likening the blueprint, that is a class to an architectural design, right? So, and how can we liken a class to an architectural design? Here, the next slide is an example about Emeka that wants to build a house, and he has an architectural plan, a plan, right? And he builds house in three different places, and almost the houses all look the same, right? With difference in paint and just paint and stuff, right? So yeah, just about saying that with a house plan you can build as many houses as you want, right? Now, we're liking that house plan towards a class. With class, you can have as many objects as you want, right? Good. So with this example in mind, let's continue. So here is all about saying, here is about the introduction to objects. So here now, when you use a house plan to build a house, you call it construction, right? But when you use a class to create an object, it is called instantiation, right? And just as you can use a single house plan to make as many houses as possible, to construct as many houses as possible, you can also use a single class to construct as many objects as you need, and that is called instantiation. Can you all hear me?
Yes, we can hear you. We can hear you.
Great. So let's go to the first lab. The first lab is creating a a class, an object. So in this practical lab, we'll see how we can create a class and object, right? So let's quickly, though I already have code examples here, but I will use a fresh one so that we can just, you know, have something practical going. So here is all about, okay, how can we create a class and how can we use, you know, a class to instantiate objects, right? So here I'll be using, I'll be creating, which class will I create? I'll be creating like a human class, right? A human class. Yeah, let's just create a human class. So I'll have this as a human class, right? So, and what are the attributes of a human? For example, you know, a human being has, let's just, for now, let's not go with best practices. Let's just have something that will come out there. So a human have a name, right? Public string, what name? Then a human public, you know, okay, public string. Let's a human have you know, name. Let's just age. Int age. So this one will be okay for us. Then what are the attributes? Sorry, these are the attributes, right? So what are the behaviors that a human being should have? So the behavior that a human being should have is maybe talk, right? So not all humans can talk, but all humans can eat, right? So let me just have this as you know, public void, you know, talk, right? So good. So this one, talk. What other behavior can a human being have? You know, public void eat, right? Good. So this is just like, you know, then we can also put our constructor so that we can be able to construct, you know, different humans and make them unique in some ways. Good. So let us take string name and int age. You know, you can generate this with your IDE, but I just want to, you know, put it here so that, you know, you can easily see how for those that are actually not so old in this, then this dot age equals to what? Age. So this is this dot age, sorry. So this is like a little model of a class. So this is like a human class, right? Now, from this class, you know, human class, we can generate as many, you know, human objects as we want, right? So let me just, you know, quickly make, you know, this main method, and let's just create a simple human called Mike, right? So human, okay, let's call him Mike equals to what? New human, you know, Mike, let's call him Mike as his name. Mike, and his age is, let's say he's 32 years, right? Good. So this process now is how you create an object. This process is called instantiation, right? Now, just as how you can use the house plan to create as many houses as possible, you can create as many humans as possible. I can create Mike. I can create maybe mice, right? Great. I can create Emeka here also, right? So Emeka here. Good. So you can create as many one as possible, and you just, you know, rename them based on this one is mice and this one is what? Emeka, yeah. So this is how you instantiate objects, and these are what? Objects of what? This class, right? Good. So this is a simple diagram or a simple flow. You know, you model it based on, you know, real things. You model your codes based on real stuff, right? Using attributes and behaviors. So these are the attributes and these are like the behaviors, right? Good. As time goes, we'll get to use most of these attributes and behaviors, and, you know, see what we can do with that. But I need to flow so that we can utilize the time. Good. So let us go into the next part, which is pillars of OOP. Please, can you guys hear me? Hello?
Yes, we can. Yes, we can, Mr. Bart.
Okay, thank you. I'll just have to ask from time to time so that I know that I'm still in sync. Yeah, because my network is not so great. Okay, so
okay, Mr. Bart. Mr.
Okay.
Are you open to answer questions because
Definitely,
some people
definitely.
have
Yeah,
questions?
yeah. Yes,
Okay,
yes, yes, definitely.
okay. Augustine, I think your hand is up. Do you want to ask a question?
Sorry, I wanted to react that I was hearing. I mistakenly just raised my hand. I'm
Okay,
sorry.
okay, okay, okay. No
Okay,
problem.
thank you.
Continue.
So, all right, thank you. So, OOP is built around four fundamental principles, which is encapsulation, abstraction, inheritance, polymorphism. These are often referred to as the pillars of OOP. These pillars form the foundation for writing clean, reusable, and modular code. They help developers model real-world entities in software, then reduce complexity and what improve maintainability, right? So these are like principles that if you adhere to, you can reduce so much complexities, and also I just wanted to know that these principles are kind of overlapping, right? That kind of overlap. For example, your abstraction in some ways overlaps with your polymorphism, right? Good. And that is one beautiful thing about them, because they're not like separately, they're not different from each other, like so more different. They are like they build on top of the other, right? And that is what makes them very, very sweet and easy to even remember and use. So the first one we'll be looking into is encapsulation. So the concept of encapsulation cut across data privacy, right? It ensures that object exposes what is needed and hides what should not be public, right? Let's take an analogy of the human body. So looking at Emeka, I love the Emeka, right? So you can see his eyes, his skin, his head, and other peripherals that are, public, but you can't see his kidney or his heart, because there is no real need or benefit of seeing these other organs. So the body encapsulates them, right? So in the next slide, we will see how we can achieve encapsulation in Java. So I use like a basic example so we can easily relate to it, right? So if you look at me now, for example, look at Mr. Sam. Basically, you'll be seeing his head, his hair, his eyes. You won't see his brain, right? There's no real benefit of seeing Samuel's brain, right? So that is what encapsulation in real practice, right? So we'll just model, so yeah, but before we go into the modeling of data using encapsulation, we'll see how we can be able to like achieve this data privacy. How can we achieve it? So we can easily achieve that using access modifiers. To achieve data privacy in Java, we use access modifiers. This includes the public, private, and protected, using the public, private, and protected keyword, right? The public keywords allows access to a given attribute or method within a class, then within the package and outside the package, and also the inherited, that is the child classes that inherits them, which we will see in inheritance. Right, so while the protected allows access to attribute within the class, package, and the subclasses, so you can't have access to a protected attribute or method outside of this boundary. Then private keyword allow access to attribute or method within the class. So that means even if you inherit it, you won't just have access to it like that. And if you are outside that class, you won't also have access to it because of the private keyword. But we'll see these things in practice. We'll see it, how do we even use them? You get, how do we even use them? So we'll see them in the next lab, right? So the next lab we're looking into is we'll see how we can achieve encapsulation in Java. So let me quickly go to the workbench, and I will just make a quick package here so that I can just separate everything. I'll call it encapsulation. So please feel free to stop me if you have any question. So for this one, I'll be modeling a human body. And sorry, I will just be using what we are familiar with, right? So that we can easily flow. So I'll be modeling a human body. So the first one, I modeled a human, but this one, I want to model a human body for a reason, right? Now, if you check, what does a human body have? Human body have, we have the public ones, which is the eye, right? Good. So I will just be making it. For now, please, for the seniors here, don't worry about best practices, right? is let's just achieve a model for now. Yeah. So first thing that the human body have is the eyes, right? The eye is public, right? So I will make like a public class I. That is an inner class, right? So an inner class called I, and I will put a public method here, that returns void, nothing. Now I'll say sites, good. And I will simply say this, this dot, I will say get class dot what, simple name plus, C's, right? So I'll just make this C's, C's, good. So human body have the eyes, right? So I will put a public eye of what I, right? Good. Now, what else does the human body have? Human body have it has the brain, right? But the brain is private, right? So I will say private. I'll make a private class. Yeah, private class brain. Okay. And I will make this method here public. I'll just make a method, right? You can make it, still make it private, right? So private void, think, right? So, and I will just quickly do some things, so that we can beat time. Thinking, you can still say this, or you can just to remove so much code, these things, right? And I'll come here. Sorry, I just need to complete this. Now I'll come here and I'll say private brain that is in a human body that is not private per se, and also it's not public. For me, I will say it is sorry to say, the human genitals, right? For example, I will tell you why the genitals is not private and public, right? For example, a married man, your genitals is not just for you alone, for you and your wife, right? Good. But your brain is for you alone. It is in your body. Nobody sees it, but your genitals, you and your wife sees it, something like that. Yeah. So I will make a protected. Let me say is genitals. Sorry to use this. Sorry. Yeah, class. Just something that we can easily relate to it. And genitals, is for reproduction or for P, something like that. Public. Void. I will make it void. P or yeah, P. Is it P like this? Yeah, P. Good. So just to quickly to beat time so that we can have enough time to ask questions. I'll make this, okay. Genitals. Good. All right. So you can have a constructor, but all I just want to achieve here is to show you how we can. So we can have a constructor, right? So let me put our constructor public human body like so, and good. So in this constructor, I don't want to accept eye and brain as I just want to just instantiate them here. For now, let's don't worry about best practices for now. Good. New eye, then brain equals to new brain, and genitals equals to what? New genitals. Good. So I won't go further to try to run this code, right? Because for us to actually run this code, we need to take it to the main method so that we can be able to see. Okay, I'll just take it there. I'll take it outside. So these ones are in different package, right? Good. So if I come to this main part here, and I bring in this human body here, let me take this down. I bring in this human body here. Human body, sorry, let me just quickly do that. Mic body. Because so new human body. Good. So to just quickly show the whole private something. Are they in the same package? I don't think they're in the same package. So let me say mic body dots. So you can see you can only get the eye, right? The eye, right? Because of what? Because of what? Because of the eye is the only public something here. So you cannot get the brain, you cannot get the genitals because of what? The brain is private, the genitals is what? Protected, right? So for you to have access to this, you need to this brain, you need to, put your public static void main inside here because they're in same package and same class for you to have access to it. But the aim of this example is just to model, encapsulation, right? What and what should be seen and what should be hidden. That is the aim of this modeling. It's not to run the code or something like that. Good. So you can see the eye in human body is public, the brain is private, and this one is what? Protected, right? Good. So that is how you think in line with objects, objects when you are modeling your stuff, object relations. So as time goes, we'll see how we can also think in line with relations, during inheritance and composition. Yeah, so I will just take this away so that we won't have this compilation error again. Good. So let's continue. I don't know if you guys have questions. Do you have any question you can ask? Now, this simple example here is telling us, okay, for example, this is like a blood capsule example, a blood capsule. You don't have to see everything inside the blood capsule, right? You are only seeing the entire blood capsule, which is what you are supposed to see. But the little medicine inside it, you don't need to see it, right? Because there is no real need in you seeing the little medicine. Though in recent capsules now, it is not transparent for you to actually see. Well, this is just like telling you encapsulation, that is capsule, right? Yeah. So good. Let's move. Let's go to abstraction. I don't know if there's any question you can raise your hand and ask here. Without that, I'll continue. The abstraction concept. Good. So previously we talked about encapsulation. Now, abstraction focuses on what an object does, or what a class does, instead of how it does it. So let us take an analogy of the heart. Sorry, I'm using these examples, but it is something that we can easily relate with, right? So the heart takes part in respiration and blood circulation, right? But we don't actually care how it does it. For me, I don't care how the heart does all those circulation, all those things that it does. But all I know that it does what? Blood circulation and respiration, right? So at least, to a non-medical student like me, I'm not a medical student, so I don't care, right? We don't really care. We don't. So we know that the eye helps in vision, and that is enough information. We don't really care how it does it. In the next slide, we will see how we can achieve abstraction in Java. Can you hear me? Hello, can you guys hear me? If you are thumbing up, I may not be able to see. Okay.
Yeah, we can hear you.
Yeah, I can hear you. Your voice is coming out.
Okay, thank you. Okay, so in the next slide, which is this next slide, we'll see how we can achieve abstraction in Java, right? So good. How can we achieve abstraction in Java? There are two main ways, There are two main ways that I'm actually aware of. Maybe there may be other ways, but the ones that I've used and I'm aware of is two main ways: using the abstract class or using the interface. So in Java, we can achieve abstraction using abstract class and interface. So an abstract class cannot be instantiated. You saw on those examples, we are instantiating classes up and down, right? But an abstract class cannot be instantiated, and its methods are mostly abstract, though you can have concrete methods. Sorry for this typo here. So you can have concrete methods, but they are mostly abstract, right? Good. So Interface is also a type of abstract class. You know, it's a type, right? It's just a kind of abstract class. All its methods are abstract. You know, all the methods in an interface is abstract, and it exposes method or functions of an object instead of its implementation. So, you know, we say that abstraction is all about focusing on what an object does instead of how it does it. Good. So interface, you know, kind of hits more on that. Interface is going to expose just what you do and not how you do it. Good. So with that in mind, let us see how we can achieve that. Let us see code examples, right? Yeah, I think we'll see how some time, right? We'll see how enough time. Yeah. So let us see code example how we can be able to achieve abstraction in Java, right? Quickly, let's have a quick demo. I will make a quick package so that I can separate most of these things. Package abstraction. Good, abstraction, right? Good. So, and I told you that we'll be using interfaces. I know we are aware of interfaces, right? So we all know about interfaces, but just bear with me, you know, just bear with me, right? So let's make a simple interface, right? So, and what interface, you know, do you think that we should make? What interface are we going to make? Let's, you know, step away from the human body. Why? Let's, you know, step away from the human body, right? Let's, you know, look at what is this? Let's step away from the human body. Let's take, you know, a quick example. Let us take, I'm thinking of an example that I will use, but I can also quickly, you know, use the human body interface so that I don't kill time thinking of a good example. But there's many, you know, examples to use. Good. So let me still stick with the human body interface. Let me just create the human body interface. Or you can also create the phone interface. But if we create the phone interface, okay, let's use the phone interface. Let's take away from the human body. So we are going to create a phone interface, right? Good. Now, this stuff is going to expose basically what a phone does. So a phone does, for example, phone answers call, right? Is it answer call or take call? So I will say public, this one is going to just run a void, right? Take call. Take call, like so, right? Then what else does a phone does? Phone, you know, void send text message. Send text message, right? Good. Let me just stick with the camel case in this thing. Send text message. And then finally, you know, I can't really say take pictures because not all phones can take pictures, right? So let's just keep it generic. So for now, let's just stick with these two. So you can see that this interface is just exposing just what a phone does, right? Or can also say play music, for example, you know, most of the, you know, recent phones we have now plays music. Play MP3. Good. So most of the phones we have now, you know, plays MP3. So we have this interface now called a phone, right? Now, it has exposed a phone's functionality, but not how it does it. Now, for you to actually have the concrete function of a phone, you need to implement this, right? Good. So let me make a new class called, I'll make a new class. Let's call it, you know, Nokia phone. Nokia phone. Right? There's a concrete class that is going to implement what phone, right? Good. So what you just need to do is you override all these methods, right? And you can just maybe just a little this in here. I'll just put these dots, you know, get class just to get the name, okay, plus, you know, takes calls. Right, and we can have almost same thing here, right? Let me just keep it simple to beat time. So here is the actual implementation, right? Good. But here, this one what exposes just what we need, just what a phone does. So if you want to like, you want to like, make a phone, right? You can keep it, generic, right? You can use this as a type, right? Good. And it kind of help you, if you start going into dependency injection and, inversion of control, all those, interface inversion and all those. Sorry if I use, the wrong word. I'm trying to hurry up. But if you go into dependency injection and interface inversion or something like that, you get to use more of this stuff of just what exposing just the functionality of your class, then having a separate implementation, right? So I don't know if there's any question in this, but I will not waste too much time in this so that we can be able to meet up. Yeah, so my network has already eaten part of my time. All right, so can you hear me? Hello guys, can you hear me?
Yes, we can hear you.
Your voice is coming out clear.
All right, thank you. Let's go to the second, to the, let's talk to the last. Yeah, I know time is fast going. Inheritance. So inheritance, allows us to pass attributes and behaviors down from a parent class to a child class, just as, example here is that, for example, 𝗵𝗂𝗶𝗁𝗂, that is Ayo has a son called 𝗵𝗂, but Ayo, he stutters, like he stammers, right? Ayo, stammers, right? And his son 𝗵𝗂 also stammers, but 𝗵𝗂 doesn't stammer as bad as his father, right? You can see that 𝗵𝗂 inherited the stuttering from his dad, but he was able to override it, he override it, and got a little, that's a mild stammering instead of, the staunch, stammering of his dad. So, but that is like a light example. So the whole gist here is that inheritance allows us to pass down attribute and behavior from a parent class to a child class, right? Good, but we'll dig deep into this, we'll dig deep into this here because there are some shortcomings of inheritance. So inheritance help with code reuse. You can keep your code simple if used well, right? So it keeps your code compact if you use inheritance well, right? Example, male and female cats are all cats, right? But we can have like a parent cat class and have both the male and female cats inherit from it. Good. So here, sorry, I read this so fast. Here is just about, okay, you have a male and female cats, right? Instead of creating two different classes of different types, male class, female cat, and male cats, why not have like a parent class? There's a parent cat class, right? And then have a subclass called male cat and a subclass called female cat, right? Good. So I'm trying to do this. So we can model this, we can model inheritance, but I won't take so much time on it. Let's just quickly model an inheritance so that we'll see what we have there. So let's quickly model an inheritance. I'll just take a package inheritance. Okay, good. And I will take the example we use in the class, in the discipline, though we don't really need that example. So what example can we use to model inheritance? Good. Let me use animal and human, just a simple example. Animal should be like a generic class, animal, right? And animal, most of animals should have, or should I use animal or just call it human? Okay, I don't think there's any need in even creating a new class since we already have like a human class here, right? So I have like a human class, right? So we can, okay, let me just do this. So I have an animal class here. So most of the animals should have, I just want to bit types, public string. Most of the animals should have, what should an animal should have? An animal has like blood. Great. Blood. Then an animal also have bone. Public string, bone, right? Bone. Boom. So let's just keep it as that, as this, so I can beat time. Sorry, I'm rushing. Right. So let's now we have an animal, right? And this is like generic. Now let us say we have like a subclass of animal, which is like human, right? So and humans also have blood and bone, but with some other further things that humans also have. So I can just create, for example, Emeka as a human. For example, Emeka class, for example, we don't need to, what can just, so Emeka, extends, for you to inherit, you use the extends the animal class, right? Good. And then once you do that, Emeka already have access to these things. Good, but though you can put your constructor here, and let me just generate it quick so that you can have that. Generate our constructor fast, and yeah, so we have this. Good. So now we have an error here. So that means that we also need to just click here, and we'll have this. So this super here, yeah, is calling the constructor of the parent class, and Emeka is also passing this in. And I won't spend time here basically, but just know that what the extend help us to like pass down all the attributes of the animal class to Emeka. And if you should do something like this, for example, let us say PSV, you can say, I'll create Emeka class, new Emeka, and let's say red and solid, and so you can have this, and you can say Emeka dot what, so you have access to what, the blood and the bone, even if you didn't define it here, or because of what Emeka inherits from the animal superclass. So all these attributes have been passed down. Good. So let's just rush. I don't know if there's any question. Is there any question? Hello? Can you guys hear me?
Yeah, we can hear you. We can hear you.
We can hear you, bro.
Okay, thank you. So let's take this slide, the inheritance paradox, right? So what is this paradox all about? So for example, Mike has a cat called 𝗪𝗁, and for you to express that relationship between Mike and 𝗪𝗁, right? So will Mike inherit from cat, or will cat inherit from Mike? Mike has a cat called 𝗪𝗁, and I want to show the relationship, right? So will Mike inherit from cat, or will cat inherit from Mike? So that is like a dilemma, right? Good. So if you don't use your inheritance well, you tend to run into tight coupling, and also forcing a class to use what it doesn't have to use, having a functionality inside a class that it doesn't really use, right? And these are some of the issues with inheritance if it's not used well. So you run into tight coupling, and you actually break the single responsibility rule, which is that a class should be focused, right? Good. So now, how can we fix this issue whereby, okay, we have two things that has a relationship, but they are not really like a subclass of each other? How can we like model their relationship? How can we do that? So we can easily do that using composition, right? Good. So composition, comes to the rescue at this point, whereby we have two objects, but they are not really direct descendants of each other. So now, but how does composition solve this? How does composition help you to model two relations that are not subclasses of each other? So there is a basic question that we need to answer, and which is what is the relationship between these two objects? For example, Mike and 𝗪𝗁. What is their relationship? Is it here we have 𝗖cie and has. So is Mike like a direct, is it a subclass of 𝗪𝗁, or does it have a relationship with 𝗪𝗁? So let me just use it. So what is the relationship between Mike and 𝗪𝗁? Is it a has, or is it a relationship? Yeah. So now let us take it easier. Let's rephrase it. Does Mike have a relationship with 𝗪𝗁, which means does Mike has a cat, or is Mike a descendant of 𝗵𝗈? So if you can, answer this question, if you can, determine what the relationship flow between two objects, then you can be able to easily model, an object's relationship that is not tightly coupled, right? Good, but there is still a clause to this. It is subjective, right? Should you use composition? Should you use aggregation, right? It is subjective, but we'll get to that, right? So if Mike if the relationship is an 𝗖cie relationship, right? That means inheritance is going to model it well for you. But if it is more of a has a relationship, then composition can model that relationship for you, right? So I may not be able to show a good example for composition due to our time, but I'll just roughly show that I already have something like that here. So I already have something like that. Let me just quickly show like something I've already prepared for it. So in case of time run out of me. Okay. So here, for example, man and animal, right? So man has a relationship with animal. So this stuff you are seeing here is more like a composition aggregation, but we'll see what aggregation is all about. Composition aggregation, because man is not, it doesn't have an 𝗖cie relationship. It's not like a descendant or a subclass of animal. An animal is not also a subclass of man. So we just use this relationship is more like aggregation / composition. But why I said /, we'll see why, right? It's actually based on the bond, like what is the strength of the relationship. That would determine if you are using aggregation as the word or as or composition as the word. But both aggregation and composition are both has a relationship, right? So this stuff you are seeing here is more of composition, and you can take it further into your dependency injection, because this cow is now being injected from the constructor, which you can take further as your constructor injection later. That's not what we're talking about now. Good. So composition versus aggregation, and this will be the last one I will take because of time. So composition and aggregation are both a has-a relationship, right? But with a little difference in depth. Aggregation shows a weak has-a relationship. Okay. For example, student shares a relationship with a university, but a student can exist without a university. You can see student is not a subclass of university, and university is not a subclass of student, but they share relationship, right? Good. That is one thing, they share relationship, which is a has a relationship, but student can exist independent of the university. So that means that this is a weak relationship, and the right word to show that has a relationship is what? Aggregation, right? Now composition shows more like a deeper or stronger has a relationship. So for example, a room and a house, you can't have a room without a house, right? But room is not like it's not like a direct subset, though you can still argue that, right? But it is subjective, right? Now, in this purpose of this presentation, let's just say that room is not like a direct subset, right? Good. So the relationship between room and a house can be seen as what? Composition, right? Because there is a stronger relationship between them, a stronger bond between them. Yeah. So let's quickly take the last one, polymorphism, and we are done. So polymorphism is means existing in many forms, right? So example is water. Water can exist as liquid, gaseous, or solid, right? Much like shape shifting, right? So in Java, there are two basic forms of polymorphism. In other languages, they are like more, right? But the ones that I've used more of the time is the two which I'm going to tell you about. We have the compile time polymorphism and the runtime polymorphism, right? So the compile time polymorphism is achieved through method overloading. Then the runtime polymorphism is achieved through inheritance and interface implementation, right? So polymorphism helps you to write flexible and reusable code, right? So don't forget to have two types of polymorphism: compile time and runtime. Compile time is gotten through method overloading, And I will just stop it at this, right? So I won't show the code example because of time, so that we can take questions, and we are done. So closing remark, OOP is basically a way of thinking in objects, relationship, and behaviors, right? So by applying the principles wisely, and favoring composition over inheritance, for example, your cow and man doesn't have to inherit from cow, and cow doesn't have to inherit or extend man class. So a better relationship should be what? Composition / your aggregation. So whenever you have something like that, always favor what? Composition. You can write a clean, flexible, and maintainable code that reflects real world models. So sorry, I rushed over this. This is basically 1 hour, and it's not enough time to like show elaborate examples, right? But just it is enough time to like throw the concept out there. So that is it. I don't know. Is there any questions? Yeah, thank you.
Thank you very much, Mr. Bright. Please confirm you can hear my voice. Can you hear my voice?
Yeah, I can hear you. I can hear you.
Okay, good. So, thank you. That's a wonderful presentation. Thank you very much. We would also share the material, so in case some of us want to go through it, as we do. So, but for now, if there is any question, please you can ask our questions before we call it a day. This is exactly almost 9:30. So, if there is a question, if there is any question, if there is any contribution, you can ask. Hello, are we together? Okay. So I think everybody, it is well understood. So there are no questions. This whole thing now, everybody has been doing it. In fact, the first, if you've written C++, you start with procedural functional um, writing when you are writing your codes. But in Java just throws you into object-oriented programming without thinking twice. So I believe we have all done this, and this is like a reminder of what we've done: method overloading, method overriding, inheritance, abstraction, the 6 pillars of OOP. So, and it's a good concept that it is very advisable that as a programmer, regardless of the level, when they wake you up from sleep, it's something you should be able to at least explain the 6 pillars of OOP. So, since there is no question, I think we can call it a day here. We really want to appreciate each and every one of us for um, for making it to this session. We really appreciate every one of us, and yeah, we'll still have, I think, two more, like one more lightning session before our monthly. I think two more lightning sessions. Yeah, two more lightning sessions before our monthly sessions, or just one. Sorry, just one. Yeah, before our monthly session, and then we'll be having 𝗲𝗻 Akeni, and like we said the last time, the first 10 participants will be gifted. So I'll see you in that session. It will be a very powerful one, and also our next coming lightning session. Uh, do have a lovely night, and really appreciate. Thank you all.